In this video, we are going to solve the Leetcode problem of the day, and the problem is count the number of fair pairs. In this problem, we are given an input of array of numbers and lower and upper bound. Lower and upper, these both are integers as well. For example, if this is an example input, then this is your array of numbers. 3 is lower and 6 is upper. Both are integers, right? So this lower and upper are basically a range. I will tell you what this range is all about. Now, what is the task in this particular problem? What we need to do is we need to find all the pairs such that if a pair is a comma b from your array, then the sum of a and b should be within the range of lower and upper. For example, if this is your array, you need to form all those pairs out of your array, pairs like a comma b, such that if you say a plus b, then a plus b should be more than equal to the lower bound but less than equal to the upper bound. That is, should be within the range of lower and upper. For example, if this is your input and this is 3 and this is 6, that is our lower and upper bound, then the possible pairs are 0, 4, 0, 4, 0, 5, 1, 4, 1, 4 and 1, 5. That is 0, 4, then this 0, 4 and 0, 5. That's 3 pairs, and 1, 4, 1, 4 and 1, 5. That's another 3 pairs. Because the sum of 0, 4 is 4, 0, 4 is 4, 0, 5 is 5, 1, 4 is 5, 1, 4 is 5 and 1, 5 is 6. Now 4, 5 and 6. These are the 3 sums I am getting out of these pairs, right? That's all within the range of 3 to 6, right? 4 and 5 are within the range of 3 and 6. But I cannot create a pair like 7 and 4. So 7, 4, if you say these are my A and B, then in this case 7 plus 4 is equal to 11, which is outside of the range of 3 to 6. So it's very simple to understand that create all the pairs out of your given array such that the sum of the numbers in your pairs A, B should be within the range of lower and upper. Now you need to consider one very important thing, that if this is your A and B and the indexes of your A and B are I, j, then I should be less than j. That is, if this is your pair, right? So you will see that 0 is at index number 0 and 4 is at index number 3. Index 0 and index 3. The condition is that if A and B are 0 and 4 and their indexes are 0 and 3, so 0 should be less than 3, which is true, right? I mean, this is fine. But that's a condition given in the question, and I would say this condition can be a bit tricky to understand, and I will explain you why this condition can be understood as some other condition which can be helpful instead of being tricky. So for now you can say that, okay, whatever A, B I am going to create, I will be less than j, where I and j are the indexes of A, B. According to the question, can I say that if this is the sum a plus b, whatever sum my pair is going to create, that should be less than equal to upper? Don't worry about the lower condition. Just consider the fact that if I am trying to create any pair, that should be less than equal to the upper. That's one condition, right? For example, if I just consider this first condition, then apart from these 6 pairs, I can also say that 0, 1 is a pair, right? Because if I say 0, 1, right, then the sum is 1. It satisfies the first condition, that it is less than the upper. The second condition, it fails because it is not more than lower. 0, 1 is 1, so it's less than upper, but it's not more than lower. So can I say that if this is my condition, and if I can find all the pairs which satisfies the first condition, and out of all the pairs which I just found, I need to be sure that it satisfies the second condition as well, right? So instead of considering both the condition of lower and upper at the same time, I am going to break these conditions into 2 conditions. First, I will find all the pairs which are within the range of upper, that is less than equal to upper. Out of these pairs, I need to find what are the pairs which are more than equal to lower. This is actually going to help me, and I will show you how, okay? For example, if your upper is 6 and if your lower is 3, and let us consider 3 different scenarios. So if A, B is 3, 2, that's fine, right? Upper condition is also fine. It's less than equal to the upper and more than equal to lower. Yes, because that's 5. So you can say, okay, this is a fine pair. What about A, B when the value is 4, 5? See, it is not satisfying the condition that it is less than equal to upper. So I don't need to check for the lower condition, and I can directly say this is wrong, or this is not valid pair. This was a valid pair. What about when the A, B is 1, 1? Then the sum is 2, right? I will check the first condition and it will check, okay, the sum is 2 and it is less than equal to the upper. That's fine. Now I will consider the second condition and I will check, is this 2 more than equal to the lower? No, it is not. 2 is not more than 3, right? So in this case, although the first condition is fine, the second condition is not fine. So I will say this is also not a valid pair and I am not going to count it. Now one of the way to solve this problem is run 2 loops. Okay? First loop is for the index number I, and for each index I, run another loop for index number j. This way you can form all the pairs and you can check for each pair that is it less than equal to upper and more than equal to lower. If it is, then you will count it. If it is not, then you will not count it. The time complexity is going to be O of n square because we are running 2 loops, right? One for I and one for j. Now the problem is the constraints given in the question is too large. So we cannot go with n square time complexity. So let's try to optimize the solution. And the first way to optimize the solution is sorting. Can I sort my data? Yes, we can sort our data, and the time complexity for sorting is going to be n log n, which is better than O of n square, right? Now if we sort our data, if I sort my array, can it save us from finding all the pairs? See, if after sorting also we need to find all the pairs, then there is no use of sorting, right? But I am telling you that if you sort your data, you can optimize your solution to save us from finding all the pairs. Now we don't need to find all the pairs, and I will show you how. So we can get rid of O of n square and make the solution O of n log n. That's the time complexity. Now you might think that, hey, if I sort my data, this condition I less than j can be disrupted, right? Because if I sort my data, the indexes are going to be changed. They are going to be all over the places, and then it will be really hard to check if I is less than j, right? Now let me tell you one very important thing which you really need to understand, that this condition can be like a very tricky condition, and I think I told you in the start that this is actually a very tricky condition. You don't need to consider this. Instead of that, if this is your condition, you can only say that I should not be equal to j. I need to form all the pairs in which I is not equal to j, instead of thinking that I should be less than j, because the operation we are performing is addition, and addition is not affected from the ordering of our element. For example, a plus b is actually equal to b plus a, right? So it is not important that the first number a should have the index of I and the second number b should have the index of j. Even the number b can be index I and number a can be index j, and that is going to be valid, completely valid. But the important thing to understand is I should be less than j. It just means that I should not be equal to j. That is, you cannot take the same number and form a pair. If this is an array, you cannot say I'm going to form a pair from this 0, 0, 0. Here I is equal to 0 and j is equal to 0. That is, the indexes are same. So till the indexes are not same, this condition will be true even if we sort our data, because I is not equal to j, right? So if you're not taking the same element and forming a pair, at that moment you can consider a pair a comma b, and you can say, okay, this is my I and this is my j. You can assign anyone the index number I and index number j. And if I is not equal to j, then I am sure that either I is more than j or j is more than I, right? So I think that's a fair assessment of this particular condition, that instead of this, let's make sure that I and j are not same. So now we are sure that if we sort our data, then this condition is still fine. Now the thing is, it still doesn't justify that sorting is our solution. That why should I sort my data? Okay, I will sort it, but is it actually going to save us from finding all the pairs? I told yes, but how can you actually think about it? And why should you think about it? See, the thing is, if you are having a solution of O of n square, then sorting will change it to O of n log n if sorting can help us to solve it. So it's actually more of a thought process that, hey, let's try to sort the data and let's try to think if I can actually solve my problem in O of n log n instead of O of n square. So I would not say this is a hard and fast rule that you just need to sort your data. I would say we are solving a problem, right? So if we are solving a problem, then we are trying something. We are trying a particular approach. So for now, let us consider that sorting can help us. Now let us see how. See, if this is your input and you don't sort it, you will have to form all the pairs 0, 1, 0, 7, 0, 4, 0, 4 and 0, 5, and then again 1, 7, 1, 4, 1, 4, 1, 5. But if you are actually sorting your data, then it's actually very beneficial. I'll show you how. Now before sorting, if I was forming a pair of 0 and 1, then I was not sure that if this is my current number, should I say that I should consider 0, 7 now or 1, 7 now? That is, if this is my pair, then I am not sure that should I get rid of 0 and form a pair of 1 and 7, or should I get rid of 1 and form a pair of 0 and 7. And this is the condition before sorting. But if we sort our data, and let's say this is 0 and 1, okay, that's a pair. Then in this case, I know that if I move in the right hand side, I am actually going to increase the sum. Because if 0 plus 1 is equal to 1, and if I move in the right hand side and choose any number, that is going to increase the sum because my data is sorted. So now I am sure that if I choose any element and choose an element in the right hand side, that is going to increase my sum. And if I choose an element in the left hand side, that is going to decrease my sum. So now I have the idea of increase and decrease of my sum, and based on that, I can actually create some answer. Now this seems like sorting might actually help, right? Now I will come back to sorting. First of all, let us try to understand very important fact, and that's the base of solving this particular problem. What you need to do is, see, if this is a sorted data, tell me what is the maximum sum pair you can create. And for that, you need to consider two maximum values, right? So if you say 7 plus 5, that's equal to 12, right? So if there is a pair of 7, 5, the sum is 12, then I can say that if I am forming any pair out of this data, it will not be more than 12. 12 is my upper limit. And what is the lower limit? 0, 1. If you take the sum of it, it is 1. So 1 is the lower limit. It means that, so if you create any pair out of your data, the sum is not going to be less than 1 and not going to be more than 12, right? This is my range. But the range which I want is 3 to 6, right? That's given in the problem. This is the lower range. This is the upper range. What are the possible values of sum of all the pairs? It can either be 1, 2, 3, till 12, right? So it can be any of this value, but not anything else, right? So these are the possible values of a plus b if a and b is a pair out of my array. Now any pair which you create out of your array, if their sum is 3, 4, 5, 6, that is, this is the range, then that's the answer we need, or that's the count, that's the pair we need to count. Now tell me, if any pair is creating a sum of 6, that is valid, right? So a pair of 6, that is 1 plus 5, is valid, right? But any pair which is creating a sum more than 6 is not valid. I am sure, I don't have a doubt, right? Any pair which can create a sum more than 6 is invalid. But any pair which is creating a sum less than 6, I'm not sure. I'm not sure if that is valid or not. I will have to check more, right? Because the sum can be 4, which is valid, and the sum can be 2, which is invalid, right? So at this point, at this border point, that's my upper range. If I ask myself two questions, that can I create a pair which is more than 6 or whose sum is more than 6? No, I cannot. All those pairs are invalid. I don't have a doubt. But can I create a pair which is less than equal to 6? That is, the sum is less than equal to 6. Then I will say, hey, I am not sure. Because it can be 2, it can be 4, it can be 1. So this is not valid, this is not valid, this is valid. So I will have to check further. So that's one information. But now I am sure that if I try to create any pair whose sum is more than my upper bound, that's invalid. So from here I can say that I need to find all those pairs whose sum are less than 6. As of now, these two will not be considered, I know. But still, if you just try to think about it, that my answer, my number of pairs lies in this range and not in the range of 1 to 12, right? So at this point of time, I can say that all the pairs whose sum are less than my upper range can be the part of my answer, or can be the count of my answer, right? Now I can say that if I calculate all the pairs till my upper range is 6. To calculate all the pairs whose sum are 1, 2, 3, 4, 5, 6, that is not more than 6, because anything more than 6 are invalid. Anything less than equal to 6 are either valid or invalid. Now another question, at this border point, if you are at this border point and if you are trying to create a pair whose sum is more than equal to 3, then can you tell me if all those are valid or invalid? So you will say, I am not sure. If you try to create any pair whose sum are more than equal to 3, they can either be valid if the sum is 5, 6, 4 or 3, but it can be invalid if the sum is 7, 8, 9 or more than that, right? But at this point of time, if I ask you the second question, that if I try to create any pair which is less than 3, are those valid or invalid? So at this point of time, I can confidently say that if you create any pair whose sum is less than 3, that is less than the lower bound, then those are invalid. I am sure that, right? I don't have a doubt. I am sure that if you try to create any pair whose sum is less than my lower bound, those are invalid. Now at this point of time, can I calculate all the pairs whose sum are less than equal to lower minus 1? That is, lower is 3, 3 minus 1 is 2. So can you find all the pairs whose sum are either 1 or 2? So it's like saying that I need to find all the pairs whose sum are within this range, 1 and 2. And before this, I was trying to find out all the pairs whose sum are less than equal to 6. And I know that my answer lies in this particular range. So if I can calculate this range as well, then the remaining range is actually my answer, right? So try to find out all the pairs whose sum are till 6 and try to find out all the pairs whose sum are till 2. Their difference is going to be all the pairs whose sum are either 3, 4, 5 or 6. That is, whose sum are within your range. So instead of solving the problem like trying to find all the pairs whose sum are within 3 to 6, I will try to find all the pairs whose sum are till 6 and till 2. 2, that is 1 less than the lower. And their difference is going to be all the pairs whose sum are within 3 to 6. You can understand it from here. This is my complete range when I'm trying to find out what are all the pairs whose sum are till 6. This is my complete range when I'm trying to find out all the pairs whose sum are lower minus 1, that is till 2. Their difference is all the sum or all the pairs whose sum are from 3 to 6. And that's it, guys. This is what we need to do. And how sorting is going to help us? See, first of all, let us try to solve this. Find all the pairs whose sum are till 6, not more than 6, till 6. Okay. At this point of time, this is my sorted data. What I can do is I can use two pointer technique. I can say this is my left pointer, this is my right pointer. If you take the sum of it, that is if you create a pair 0, 7, then the sum is 7, right? Well, 7 is more than 6. At this point of time, I am sure that if I try to create any pair with 7, those are not valid, right? Because if I'm trying to create a pair of 7 with some number which is the lowest right now, because the data is sorted, so I know that the first number is the lowest number. And if I'm choosing the lowest number and then also the sum is more than the upper, then I cannot choose this with any other number. So this is not going to be the part of any of my pair. So now what I can do is I can say, okay, I will keep you up. You are going to be the left index. Now you are going to be the right index. I'm going to move my right index in the left hand side. Moving in the left hand side will surely be a number which is less than 7, and that is because we have sorted our data. So you can now see that how sorting is actually helping us. Now the sum of 0 and 5 is 5. That's within the range. That's less than equal to 6. So at this point of time, I am sure that if I just try to find out all the pairs whose sum are till 6, then I know that 0, 5 is valid, right? Now if 0 and 5 is valid, I am also sure that 0, 4, 0, 4 and 0, 1 will be valid, and that is because this is a larger number and this is a smaller number. If I'm trying to create a pair of large and small, and if I reduce the larger number, then I am sure that the sum which was 5 earlier will be reduced, right? It can either be 4, 3, 2, 1. So if I create a pair of 0 and 5 and that's equal to 5, then 0, 4, 0, 4 and 0, 1 will never be more than 5. And you see what we need to calculate is all the pairs whose sum are till 6. So at this point of time, you will see that I don't need to find all the pairs, because if I'm sure that 05 is a valid pair, then 040401 is also valid. How many did we got? This is at index number 4. This is at index number 0. This 0 index is creating a pair with index 1, 2, 3 and 4, right? 4 pairs. So at this point of time, I can say that I have got 4 pairs, that is the right index 4 minus the left index 0. What are those 4 pairs? 05, 04, 04, 01. These are the 4 pairs which I can create if my upper bound is 6. That is all the pairs whose sum are till 6. So I can say I got around 4 pairs. Now, if this is your left, this is your right, and I know that this is a valid pair, I calculated all the pairs within that range. So now at this point of time, I will try something more. That can I say that this is my left and this is my right? Can I actually try to increase the sum? And that's because we are actually moving in the right hand side. So this is going to increase the sum. Okay, 1 and 5. What is the sum? The sum is 6. So still we are within the range. The range is 6, right? So again we can say that if you try to create a pair of 1 with 5, that's a valid pair. Then if you try to create a pair of 1 with 4, 1 with 4, that's also going to be valid. That is all the pairs you can create within 1 and 5, with 1 as the first element and the second element being 4, 4 and 5. How many pairs have you got? This is at index number 1, this is at index number 4. 4 minus 1 is 3. 3 pairs. That's because 1 5, 1 4 and 1 4. So you got 3 more pairs, right? Plus 3. That's total 7. Now again, this is your left, this is your right. So since you are still having a valid pair, we are again going to increase the sum to see if I can actually increase the sum and get another valid pair. Okay, so this time this is the left and this is the right. The sum is 9. If the sum is 9, which is more than my range, so I am sure that okay, this 5 is done. It cannot pair with anyone else because now it is creating the sum out of our range. Okay, let me go back. Let me go in the left hand side to reduce the sum. So at this point of time, this is left, this is right. The sum is still 8. That's still more than our range. So what we are going to do is we are again moving our right pointer in the left side. Now how can I move my pointer left and right? That's because my data is sorted. So this is left, this is right. At this point of time, since both are on the same index and we don't need to consider anyone who is at same index, then I can stop. I got total 7 pairs whose sum are within the range. Those 7 pairs will have a sum of 1, 2, 3, 4, 5, 6. But I need to remove all the pairs whose sum are 2 or 1. So let us try to apply the same algorithm and try to find out whose sum are less than or equal to 2. That's 1 less than our lower bound. So 1 and 2 will be covered. So if you will try to find out using the same algorithm, you will see that 0 and 1 is one of that pair. 0, 1 will have a sum of 1. That's within this range. So I will say 7 minus 1 and that is equal to 6. And if you will see, 6 is actually the output for our problem, right? So that is how we are going to solve the problem. We are just going to sort our data, then assign our data a left and a right pointer. And then we need to calculate for the upper bound and for the lower bound minus 1. So let me take you back to the coding editor to show you how we can solve this particular problem. So what you need to do is you just need to sort your data initially, and then you will need to return find the number of pairs till the upper bound minus find the number of pairs till the lower minus 1. Okay, so now we need to see how this find function works. N is the length of our numbers. Then we have a left pointer at index number 0, the right pointer at index number n minus 1. The result is going to store the number of pairs which we can form whose sum range is less than equal to mx. Now we are going to run a loop till left is less than right, and then if the number left plus number right is less than equal to the mx, at this point of time I can say result is equal to result plus right minus left, right? That is the difference between the indexes left and right. Then you need to increase your left, but if the sum is more than mx, more than the range, then we need to decrease our right index so that we can choose a lower number. After this while loop, we can just return the result, and that's the complete solution for this particular problem. So once you submit the code, you will see that this is actually a good solution. Memory wise as well as runtime wise, it's actually pretty efficient. So that's the complete explanation of this particular problem as well as the solution approach, and that's it for this video as well. So if this video helped you to understand the problem and the solution as well, then make sure that you hit that like button. And if you have not subscribed to my channel, then make sure that you subscribe to my channel as well. And I will see you guys in the next video.